So, guys, I hope we can start the session right now, but I think the count is still very far below. And please confirm me that you can hear me and you can see the screen which I'm sharing right now. I hope I'm audible to everyone, right? So I can see there are only 24 participants right now. So if some of your friends or someone might be joining the session, please make sure that they join it fast. So we'll be learning about decision trees in this session, and after completion of the decision trees, we'll get back to the metrics, how this classification is being evaluated. And after that, we'll also get to know how we'll be doing the fine tuning, and we'll also learn about an algorithm that is naive based. So it's also a classifier based algorithm, and we'll be using probability based functions in classifier based algorithm. So let's get back into the topic. First, we'll discuss about this decision trees. So first, decision trees are nothing but a tree-like structure which you'll be seeing every day. So imagine that you are looking at the tree right now. So the first thing that we see that helps a tree to go is called as root node. Whenever seeing a tree, whenever you're seeing a tree, so that main thing, the component trees for a tree is the root. After the roots, the branch will grow up. After branch, will have be some stems. So after the stems, we'll have the leaves. So this is the process we'll be seeing for a tree entirely. So whenever you try to see this tree, this is the first flow. Okay, whenever you try to sow it, seed in the ground, some tree will be elapsed. So for the tree to elapse, first the roots will be grown. After the roots, the stem. After the roots, the branch. After the branch, the stem, and after that leaves. So here we'll be having levels. Consider level 0 is like the levels will be from gradually from top to bottom. So considering the root node that is at level 0 is called as like problem statement or some other thing. So it is highly understandable by every human because it is highly visually represented, and also the math behind the decision tree is very minimal, and also you can understand the math easily compared to other algorithms. So decision tree is nothing but decision tree is nothing but a flow chart. Whenever you're seeing a if then else questions, this is what decision tree is. So to make the concept crystal clear, let's understand some scenarios. Okay, we'll get to know about the scenarios. So the main goal of the decision tree algorithm is to build a flowchart. So by building a flowchart, we'll have our data into smaller and homogeneous groups. So okay, whenever you're building a flowchart, you will divide the problem into a statement where you'll be performing this task if some part of the problem will happen, or you'll perform these kinds of tasks when some part of a problem will happen. So the best thing it has is it will separate the entire tree into different classes. Okay, so whenever you're separating this entire tree into different classes, based upon the classes, your outcome may occur. And also the algorithm is always looking for questions. Whenever you're trying to go for the root node, you'll see that the root node itself is a question. And after root node, at every level, you'll be having questions. Suppose if you think like if you're understanding this session, then the question will be who is teaching your session? What is the session? Okay. If you're enthusiastic to the session, so we'll ask you doubts like questions like what is the session name and everything. So based upon every question, if you're answering, so we'll be having a yes and no. Based upon the yes and no, we'll be predicting the output based upon the decision tree. Okay, let's take an example. For that, first let's finish this theory part. So the model will be a best for learns the best questions in their order. So the first thing is it will learn what are the questions that are there and will answer the questions in the best order itself. So it can handle both numerical and categorical features. Suppose if you want to figure out the future price of gold, so what we'll be doing is we'll be giving the previous gold data. In the previous gold data, what we'll be performing is we'll be giving the data where I hope I'm audible to everyone, right? Guys, give some response that I'm audible to everyone. Yeah, thank you for the confirmation. So if you want to know the future gold rates, what we'll be doing is we'll be focusing on few targets. For the few targets is gold price is predicted by few features. Okay, suppose we're having some war right now. So if there is a war in our country or in some neighboring countries where we are trading the gold with, so the gold price will automatically decrease because at times of war, nobody cares about gold. They only cares about the manpower and the weapon power what they're having. Okay, and also we'll be considering about international trade. If India is not having international trade with certain countries like Russia, Dubai, United States, and China, there will be no gold power that we are having. So what we'll be doing is we need to consider every factor. We need to consider every factor, and just like we have considered these two examples, such as war and international trade. Suppose if the war is happening, and if it is a yes, the gold price will decrease, and if it's a no, the gold price will increase. Okay, and also we'll be having certain months. In certain months, gold price will increase and gold price will decrease. Suppose as per of India, we'll be having Akshaya Tritiya and some other seasons where we'll be having gold offers and gold price increase and everything. And also the peak month of marriages is around September post year. So every late year, like December, November, September, October, in these months we'll be having marriages mostly. So it's estimated around 450,000 crores revenue that will be generated from these marriages every time. So whenever we generate this kind of revenue, in this kind of revenue, approximately 20% of the revenue is specified to gold. So whenever you're trying to perform some activities related to gold, gold price will automatically increase. So based upon every factor, we need to consider. So whether the factor is categorical or whether the factor is numerical. We'll consider the factors and we'll be having two questions, whether it is a yes or whether it is a no, or whether it is greater than 20, less than 20. So whatever the question you're having, it needs to have two answers. So based upon the answers, we'll be going to the next statement. So this decision tree is nothing but a series of questions. And in the series of questions, the first level is an important series where this series, like suppose, let's take this example of I want to play outside. This is the most famous example that will be taken every time when you learn this decision tree or some other thing. So I want to play outside and the climate is sunny, rainy, or some other thing. So at level 0, we'll be having problem statement. At level 1, we'll be having whether it's sunny or raining. So even if it's sunny, if the humidity is high, I won't be playing. If it is sunny and the humidity is low, I will be playing. So even after having first rule check, we need to check the second rule. So every level of the dictionary plays a major role in identifying and predicting the output of the final reason. I hope you guys understood this thing. So if you look at this thing, this is a complete tree. These are the leaf nodes. Whenever you say leaf node, these leaf nodes are the predictable or the outcome nodes. You can call these leaf nodes as predictable or outcome nodes. So what is a decision tree? Like what are the components of decision tree and everything? So what we'll be doing is we'll be having a root node first of all. So what So we'll be having a root node. This is the first thing. It contains the problem statement and everything. After that, we'll be having internal nodes. As we have discussed that for every root node, we'll be having branches and everything. So these branches are nothing but the internal nodes. So internal nodes plays a major role by detecting the problem statement to go further until the leaf node. So as we have discussed here, so this is the root node and these are the internal nodes. So this is decision tree node, this decision node. These two decision nodes are the internal nodes. Coming to these three leaf nodes, these are the outcome nodes. Okay, now if you can see, so these internal nodes represent a test or decision based on the feature. The outcome of the test is example yes or no, less than 50 or greater than 50K. So suppose if I want to go to a, if I want to purchase gold, but I only have 60,000, I only have 40,000 in my wallet. So what I'll be doing, I'll be going to gold shop. So okay, now I'll be comparing the gold. If the gold price is less than 50, I'll be purchasing. If my gold price is less than greater than 50, I will not be purchasing. So if I'm not purchasing, I'll be waiting for 3 more months, or if I'm not waiting for 3 4 months. So if I'm waiting again, I'll be coming back to the price again. I will coming back to the shop again. If I'm coming back, what is the price at that time? So for every follow-up question, you'll be having an answer, and for every answer, you'll have a follow-up question. So remember this root node, internal nodes, branches, and leaf nodes. So this decision tree is very helpful for everyone. Very honestly very helpful. It is very easily understood by everyone because it is highly visual. So that whenever you see this decision tree, you will clearly understand. So as you can see, this age over 30. If it is a no, the salary will be around $2,500. If it is a $2,500, you can get a gold loan. But if it is not $2,500, you don't get a gold loan. And if the age is greater than 30, and if you're having less than two children, then you'll get a loan. If you're having greater than two children, then you won't get a loan. Okay, there's some kind of metrics that banks will follow. Whenever you're having more than two children, so you need to maintain these two children's income, the maintenance and everything. So okay, you need to feed them, you need to pay the school fees, you need to pay for their maintenance, eating food expenses, going outside and everything. So if your age is not greater than 30, and if your age is around $2,500, okay, so that's some decent income you'll be maintaining. So then what we'll do, we'll be granted a loan. This is a basic pay a person will get. Suppose instead of the 2,500, consider it is 25,000. Okay, if your age is over 30, if it is a no, if your salary is greater than 25,000, then you'll get a no easy. Then you'll get a loan easily. If not, you need to improve your salary because whenever your salary is less than 25,000, it's not possible to get a loan because the salary is availing that they'll consider whenever they're giving a loan. And if your age is over than 30 and you have 3 or 4 children and two of them is studying graduate BTech or MBBS, like medical or some other thing, then you need to pay college fees, hostel fees, and everything. So it will be a lot of burden on you, even if you have a greater than 25,000 salary. So what the banks will think is based upon the criteria and mathematical equations they have, the bank will have every mathematical equation. So after the equations they'll be having, they will tend to give you a loan or not. So how a decision tree works is, so first we'll consider the root node, the tree algorithm. We'll consider root node. Every node we'll get to know the what is the functions we'll be having. We'll be having a root node. For every root node, we'll be having a follow-up path. Okay, for every follow-up path, we'll be having a question. So here we'll be having a matrix called purity. Purity is measured by metrics like Guinean impurity or entropy. Okay, we'll be having an entropy where it's a mathematical function. This entropy is used to evaluate whether the outcome which was given by the decision tree, whether it is likely to occur or not. Whenever the entropy is greater than other outcomes, then we can say that this decision tree is working fine than other things. you see the last point, the goal is to reduce uncertainty at each step. That means whatever the uncertainty that is, suppose if you're thinking what I could do, what I might do. So okay, then you're in uncertainty state that you don't know what to do and what not to do. Then you will be having the questions, what is thing or what I need to do and what I don't need to do. What are the pros and cons? Whenever you think like that, so you'll be eliminating few points. Whenever you eliminate few points, it will be easier for you to go to the outcome, final outcome. So what we'll be doing here is we'll be evaluating the follow-up questions. Whenever you're evaluating the follow-up questions, what we'll be doing is we'll be reducing the points which we'll be having in our mind. So whenever we reduce points, we will be having some set of points that are vital to evaluate the outcome. So when you get to the last bottom 5 or 10 points, then you can evaluate clearly by understanding those points and what might be the outcomes for every point when you perform something task that is related to this thing. So then there will be overfitting problem in decision tree. These decision trees can become very complex, and overfitting the training data. Whenever you're having two noise, okay, whenever you're having two noise and the specific patterns they're having very long, so these patterns will be overfitting. So what is the main reason is memorizing is the main reason. Whenever having a tree larger than certain content, so it will be harder to memorize the previous information. Whenever you're following up with the questions, yes, no, at every end you need to validate that whether I'm doing the correct thing or not. So if I want to validate by going back to my distance, so the previous distance which I took, I can't remember because the tree is very long. So this is very challenge model. So we get to know how we will be overcoming this decision tree overfitting model. Underfitting is too simple problem. This overfitting is 2D problem and underfitting is called as too simple model. So this is called when we don't have the enough data or enough questions to validate and evaluate the model. Okay, suppose if you don't know what is the reason, like how to tackle this kind of situation or how to tackle this kind of solution, then it will be in the problem of too simple. So whatever the model it is having, it doesn't have the enough data to train the model. Suppose as we are having this data, like if you want to play outside, then I will not have the enough data to go outside or not. I don't have the humidity data, I don't have the wind data and everything. I only have the temperature. When I only have the temperature and I want to, and if I went to the outside and if the wind is too high and I want to play badminton, the shuttle will not be in a stable position so that I can play badminton. So this is a false outcome that the dictionary is giving. Okay, no, I need to consider another one outcome which will evaluate the wind and everything. So this is called as underfitting, which will not understand every pattern that is there in the dictionary. So this is called as pruning. Pruning is a state where you will cut off the branches which will be not helpful for the outcome. Whenever you see that these kinds of branches are not helpful, okay, whenever you feel these kinds of branches are having low importance in the decision tree, then you will cut them. Pruning is a process where you will be performing in decision trees. Okay, so you'll be having max depth for everything. You'll be having a maximum depth. After going to the maximum depth, you'll be pruning for every branches. Once you prune the branches, these branches will be eliminated from the memory, and you can have new data stored in the memory as memory has been deleted. Preventing underfitting. So to prevent the underfitting, what we need to do is first we need to check whether the underfitting is because of high bias or not. Okay, if it is because of high bias, then we need to train the model again and again with precise data. Okay, and also we need to give the model deeper, and also we need to split with more patterns so that it captures better. So based upon the model we are having, decision tree model we are having, if it is not with the suitable questions, if it's not having suitable patterns or some other thing, then we need to check whether we'll be able to add some more patterns so that this decision tree will capture the underlying patterns that will detect the problems. Sometimes what are the problems which I told you, it will not capture the problems which that will be facing. So if you want to capture every minute detail of the problem, then you need to have few more questions. So these few more questions will help you to analyze this pattern. Just like if you watch some CBI or CID episodes. So in these episodes, they will be asking every question in forensics. So this question will get them to a conclusion where they will understand that what is the main what is the main motive of this murder and some other thing. So this is the way where you will be applying efficiently in a real world problem. So these are the advantages of decision trees. It is easy to understand because, as I told you, it is more visually intuitive, and also you can understand by just looking at the image. And also, it requires little data preparation. You don't need to handle both numerical and categorical without extensive scaling, and it can also handle nonlinear relationships. What are the non-linear relationships we're having? We can also handle that, and the feature importance can also tell us what is the features that will be influential. Also, if these features are not influential, we can directly prune them. Disadvantages of this decision trees is overfitting. So whenever you're having overfitting, then we need to prune the data. But first, we need to find whether the data is getting overfitting or not. So that might be a problem for us. And instability. Small changes in the data can later very different tree structure. Suppose, as I told you, I want to play outside and I went outside. But when I went outside and I found wind in the out environment where I'll be playing badminton. And as I told you, whenever we're playing badminton and heavy wind, the schedule will not be stable condition. So this is a situation where you have a line of questions to this decision tree. Whenever you have a simple line of questions, the entire decision tree will be changed. The entire outcome, what we're expecting, will be changed. So this is something which we need to consider into. Other basic use case of decision trees: customer segmentation, credit risk assessments, disease diagnosis, market campaign optimization, and some other things. So we'll be implementing decision trees with scikit-learn decision tree classifier or scikit-learn decision tree regressor. Let's get into a model where I'll be explaining you decision tree. Allow me a second so that I'll share my whiteboard. So we have seen an example where decision tree is used for disease diagnostics, right? So we'll be taking an example of disease diagnostics, and we'll get to know how a disease is classified and what are the diseases that we'll be having. I hope you all can see my screen. Give me some acknowledgement that you can see my screen. So now let's consider this is the root node. This root node is where you're feeling tired. Okay, consider you're feeling tired. Now you went to the doctor and doctor will ask you few questions. So these questions will define whether you're having some disease or whether you're having some cold or some other thing. So help me with this thing. I'm not a maybe a student. I don't know much about this cold, fever and everything. So let's take an example that he'll first ask you, are you having a fever? That is what the doctor asks you whenever you say, I'm feeling tired and go to the doctor. And the doctor asks you whether you're having adequate sleep or not. And ask you what is the food that you ate, recent food item that you ate. And if you say, if you're having a fever, he will predict you Dolo. He will give you some Dolo tablets or some syringe or some other thing. If it's a no, let's get back to that. If you're having good sleep, then he will further diagnosis. If you're not having good sleep, then he'll tell you go and have good sleep. So what is the food that you're eating? If it is a healthy food, sorry. If it is a healthy food, then the doctor, then if it is a yes, we'll be having further analytics. So let's go back to this healthy food. If it's a yes, then he will evaluate more. If it is a no, then he will ask you to eat healthy food. So guys, help me with this thing. Is it a yes or no? Until the thing which I've drawn. Okay, only for like consider the scenarios which I will telling you. So you will be going to a doctor and you tell that you're tired from past few days, and you tell the doctor will start asking you questions. So the first thing he'll ask is whether you are you feeling any fever or not. If you will tell yes, he will give you some tablets and he will send you. If it is a no, then he will again like, will then check your temperature. If fever is found, then he will give you tablets. If there is no fever, then he will give you some antibiotics, not antibiotics, some nutrients that will boost your health. Okay. And coming to the sleep, if you're having less sleep, he will ask you to go and have adequate sleep. If you're having adequate sleep, but if you're having these kinds of issues, then he will ask you what is the food that you're eating. We have already considered the food, right? So we'll get back to some other thing. So now he will check whether your eyes and some other thing where we'll find something about your sleep and other data. So now if we find out that we're having some disease related to sleep, he will give you medicines and he will give some antibiotics. If no, he will write some medical checks like MRI or some other thing. Okay. And coming to food habits, if you're having healthy foods, then that's great. If you're not eating healthy foods, then he will tell you to go and eat something healthy so that you'll feel something better. And if you're eating healthy foods and you're feeling tired, then he will ask you your food habits, your sleep cycle, and everything. If everything is perfect, then he will ask you to go and take some tests. After the test, if you have anything positive, like check example of COVID. Nowadays, COVID cases are rising again. So let's take this example. So if you got negative in COVID test or some other thing, then he'll only give you some nutrient tablets so that it will boost your stamina and it will boost your health. I hope you guys have understood this thing. This is how a decision tree works. So for every node, you won't be having a leaf nodes or branches. Only for whatever the node, we'll be having a follow-up question. We'll be having the answers. Give some response that you understood this thing or not. And we'll go with some other example. We'll take some other example. For this example, let's take this thing. So this is a famous example that we'll be considering everywhere. This is Outcast. So for every outcast, you'll be having temperature. You'll be having temperature, whether it is sunny, rainy, or cloudy. For sunny, this is for cloudy, this is for rainy. So this is for playing badminton. This is for playing shuttles. So I'll be playing shuttles upon these conditions which I'm drawing right now. So outcast is nothing but the temperature. So considering this thing. So if it is sunny, what I'll be doing? If it is sunny and if my age is greater than 20, age is less than 20. Do this thing also. Age is greater than 20. Age is less than 20. Coming to cloudy, I'll be playing my shuttle. I'll be playing badminton whenever it is cloudy. Okay. Even my age is greater than 20 or less than 20. Because cloud is a perfect weather. You'll be having clouds, you'll be having no sun, you'll be having no wind and everything. So whenever you're having this kinds of thing, okay, let's get to this thing also. So we'll be checking wind connection here. So the temperature is cloudy and the wind is high. Then I'll I'll not play. When the temperature is low, I'll be playing. Okay, I hope you understood this thing. And coming to age factor, why I took age factor is because even some people, okay, let's take an example. Whenever you're a child, you always want to go and play in rain. But coming to elder, whenever you're becoming older, you'll be losing the interest to go and play in the rain. So that is what the reason I took this train example. But coming to sunny, you will not be interested to play in sunny even if you're in elder or even if you're older. Okay, so let's take this condition of sunny where we will be having some specific conditions where we'll check with humidity. So if my age is greater than 20 and if the humidity is low, humidity is high, we will be taking another thing, that is humidity is low. Coming to this thing, whenever it is raining, we'll be having wind, right? Wind is high and the wind is low. Whenever it is raining, we don't have any humidity. Make sure this point. Why I'm not writing humidity here? Because whenever I'll be having raining, I won't have humidity. This is how the dictionary works. So the first thing is outcast. How is the outside environment? We have it the out scenarios: sunny, cloudy, and rainy. Okay, now coming to each individual scenario. So if my age is greater than 20 and the humidity is high, okay, if my age is greater than 20 and humidity is high, now what I'll be doing is I'll be playing this thing, because you're like you'll only get a few chances to play shuttle. So what you'll be doing is you'll be playing the game irrespective of the scenarios. When your age is greater than 20 and the humidity, suppose your age is less than 20, and if you want to play the game, age is greater than 20, age is less than 20. Okay, now when your age is less than 20, you'll be thinking, I want playing tomorrow. I can play this session, like I can play this game today. Coming to this thing where the humidity is low. Now, when the humidity is low, even my age is less or my age is more, I will tend to play. Okay, when there is no humidity, it is favorable by everyone, right? So if there is no humidity right now, I want to play when there is humidity or not. So coming to this, wind is high. So whenever the wind is high, even my age is greater, the cock will not perform stable. Okay, the cock will be not be performing stable. The cock will be going to the wind side. So if even if my age is more than 20 or less than 20, I will not be able to play this shuttle in windy condition and when it is raining. Okay, when my age is less than 20, when the wind is low, I'll be playing. And my age is greater than 20 and the wind is low, I will not be playing because I don't want to get into rain. And because whenever you become elders, you'll be having some responsibilities to go to college, to go to like job or some other thing. Okay, when you go to this rainy situation and you will be playing, you'll be getting tired and you will not be going to the office tomorrow. So based upon every condition, you'll be checking and you'll be coming back to the valuation metrics. So this is the final thing. This is the final node, that is the leaf node. So these leaf nodes will predict the outcome of the situation. What are the situations that we are having? These leaf nodes will predict the thing. I hope you guys understood this thing. Okay. After the example I took, it might be messy, but you can take some easy examples and try to understand this thing. Give me some response that you understood this recently or not. If you didn't understand, we can take another example. Some responses from everybody to know that you have understood the session. If not, we'll go back to some previous examples and we'll get back to our decision tree in better. Not the emojis, I need some responses in the chat. If I can see that many of you can understand this examples and decision tree, then we'll get back to another topic. What about yourself? You didn't text in the chat. Do you understand this or not? So now we'll be learning about naive Bayes algorithm. I hope you guys have understood this decision tree. Please give me some response that you can see the screen right now. So now we'll be getting to learn about this naive Bayes. It's a really intuitive problem and powerful calculation algorithm that you'll be learning. So this is called as naive Bayes. And the key things that we'll be doing is, so naive Bayes is a probability based classification problem. Okay, it will be classifying the task based upon probabilities of data points where it is belonging to, and it will assign the data points to a class with higher probability. Whenever the probability of the class is more, then the data points will be assigned there. So it's particularly effective for text classification and spam detection. Whenever you think the spam can be a spam or not spam, so it will be mostly applicable in these kind of situations. And it is a fast and efficient algorithm, making it great for large data sets. So as you can see that it says that it's based on Bayes theorem. I hope you all know what is the Bayes theorem. Bayes is a probability theorem that we seeing in the upcoming slides. If you remember, please type the Bayes theorem in the chat box. If you don't, then no worries. We'll get to know about the Bayes theorem. And it's native because it makes a simplifying assumption about features. So naive is nothing but a assumption. So whenever you see naive, it will classify the thing straight away. So whenever you see naive is nothing but assumptions. Okay, it will assume all the features that we are looking at are important, and these are independent to each other. Okay, when I meant independent, this independent nothing but whenever I took the previous examples, that is one is sky, what is the temperature it is, and also the wind condition. So these things are independent to each other. Even if it is rainy, we can have wind higher or wind lower. So these things are not interrelated to each other. So if coming to these scenarios where humidity and rain, it is interlinked to each other. Whenever it is raining, we will not be having humidity. But coming to rainy and wind, these are not interlinked to each other because even if it is raining, the humidity, the we say the wind can be high or the wind can be low. So based upon these naive assumptions, we can classify these probabilities. So as we learned previously, this is a probability based classification problem where it will classify the classes based upon the probabilities. Okay, whenever the class is having higher probability, it will assign the data points to that class. So the heart of this naive Bayes algorithm is a fundamental concept with the help of Bayes theorem. Okay, it's a mathematical formula that will be allowing us to update our beliefs about an event based on new evidence. So think of this like something you'll be having an initial belief about something, and you'll getting new information, something which you think it will be a truth or something, and then you'll be getting some new information. Bayes theorem will help you to get to how to combine this new information with your belief, get a revised more accurate belief. So I hope you understood this thing. Suppose let's take an example that you believe in something, but again you got to know some truths about the belief. Now what you'll be doing is you will be evaluating this belief and the truth that you know already. So what we'll be doing is we'll be evaluating what is right and what is wrong based upon the truth we have learned previously. So this is a Bayes theorem. This is a Bayes theorem that we'll be talking about. P of A by B is equal to P of B by A into P of A by P of B. So whenever I mention P of, this P of is nothing but probabilities. So this calculates the probability of event A happening given that event B is happened. So let's take an example. So this is like an example where suppose it's a match of India versus Pakistan and I want Virat Kohli to hit a half century. Okay. So I want Virat Kohli to hit a half century and I want India to win. Now what is the theorem will become is P of A is India is winning, P of B is Virat Kohli hitting half century. Okay, no, I want Virat Kohli to hit half century first because first after hitting, after batting and bowling only, we'll be getting to some consideration that the match is won or lost. Okay, the first event that will occur is when India is batting first or bowling first. Before getting to know the results, we'll be getting to know the Virat score's batting. So what I'll be doing is I want to know whether Virat will score half century or not. So that is the probability of B event B. So B will happen first. After that, after the happening of the event B, I need to understand that event A will happen or not. So even if Virat Kohli hits half century, India lost few matches. Even if Virat Kohli hit a century, India lost few matches. Now what I want is even if Virat Kohli hits this half century against Pakistan, I want to have this match win against Pakistan. That is what P of A by B. So P of B by A means hitting a like hitting a half century. So we can take this into the mathematical terms where P of A by B is considered as a goal, P of B by A is a likelihood. So this might happen when this kind of event will happen, and P of A is a prior probability. So at most, we want India to win the match even Virat Kohli hits a half century or not. That is a patriotism we are showing throughout the country. And coming to P of B, that is the evidence or marginal probability we'll be having. But we want India to win the match, but at the same time, you want Virat Kohli to hit a half century. That is what your mind wants. So that is the marginal probability that we'll be looking at. So if you look at this P of class by features, P of features by class, P of class, P of features. So we want the probability of a class with given features. As I already told you, naive means assumption. So the naive assumption, why naive means the presence of this feature doesn't affect the presence of another. Whenever Virat Kohli is hitting a century or half century, this will not affect the total entire outcome. So even if Virat Kohli hits the century, other team players needs to perform. Okay, even if he's hitting the century, it's not a direct outcome. It is a part of the outcome, but it's not the direct thing. Okay, if he hits the century, we'll not directly assume that we won the match. So this assumption is always false in real world data, but the model still performs surprisingly well because based upon the probabilities we are having, it might occur to the conclusion that the model will outperform the events. So this naive part will always think that all the features which we are having are independent to each other. Even if the ball that is bouncer, even if the bowlers are great, Bumrah, Bhuvaneshwar, and everything, and also the batters, Virat Kohli, Rohit Sharma, Hardik Pandya, even though they hit half centuries and centuries, this is not directly dependent that we will be winning the match. This also depends on the other team, how they are performing and everything. So based upon this thing only, we'll be getting to the conclusion that we will be winning the match or not. So we'll be having different flavors of data. That is Gaussian naive Bayes, multinomial naive Bayes, Bernoulli naive Bayes. Okay, so for continuous numerical data, we'll be using Gaussian naive Bayes. For discrete, we'll be using multinomial. For Bernoulli, we'll be using presence and absence of a word. For binary features, whatever you're having. Suppose if you think it might be a yes or no, if you think it's a 0 or 1, then you'll be using Bernoulli naive Bayes. While coming to the multinomial naive Bayes, you'll be using whenever you're having categorical data. Hope you understood this right. So this Gaussian naive Bayes, whatever we're discussing right now, this is used when the features are continuous, like temperature, height, and some assumptions that we're using. So whenever this we are having these kinds of features, temperature, height, distance, and everything, then we'll be using this Gaussian. But coming to this multinomial, this is one we'll be using for email example. So what are the email which we are using? If it is a spam or not spam, it will count whether how many emails that we got, there's a spam email, or how many emails that we not got is not spam emails. And coming to the binomial, it is used when features are binary. For example, if a word appears in a document or not, regardless of how many times. Suppose the word is appearing multiple times also, we'll consider it as a single time, but we'll be counting whether the word will appear or not. Okay. So this is one of the example of Bernoulli naive Bayes, where we'll be having only 0 or 1 probability. So the advantage of naive Bayes is simplicity. First, we can take this as simplicity because it is easy to understand and implement. So another thing is fast and efficient. So it is very quick to train and make predictions. And also, even with large data sets, calculations become very straightforward. Coming to this thing, it is good for high dimensional data. So performs very well with many features. As we are having many features like height, distance, and everything, it will perform very well as we are compressing data with probabilities. Whenever we're having probabilities, we'll be getting the probability that we get the outcome with most occurrence outcome. Coming to scalability, it scales well with a large amount of features with data points. So the disadvantage we'll be having is zero frequency problem. If a category in the test data wasn't seen in the training, it might assign zero probability. So whatever the training that we'll be doing, if the data is not seen before, the category or the if a classification is not seen before, it will give you zero assumption, and it will assume that it is not trained on this, and it will give you zero probability. And the naive assumption what we are doing. So the independence assumption is really true. But as we are discussing this example of cricket, so this independence assumption will be true, but only sometimes. Okay, when multiple players hit centuries, then it will most likely that the match is won by the team who had more centuries. If you consider the example of 2016, where RCB hit more centuries in a team, so Virat Kohli and David Ellis is two players who hit consecutive centuries in a team, so that at that time, when the time is 2016, if your score is par 200, then we can automatically consider that the team who is crossing par 200 is winning the match easily. That is the thing, that is a limitation that we'll be seeing in the ABS. The use cases for naive Bayes is spam filtering. What are the word counts that we'll be having? So we'll be counting the words and we'll be categorizing whether it is a spam or not. Not sentimental analysis based upon the probability will be determining whether the text is possible, positive, negative, or neutral. Also coming to medical diagnosis, so it's based upon our symptoms. So we'll be having a probability that we might have fever. So if we are having fever, then we might have a cold also. That is some kind of probability we'll be doing with this naive-based use cases. So for implementing naive-based, we need to get the library that is sklearn. So scikit-learn is the import library that we'll be using to import this naive-based. So for that, we need to get scikit-learn. After that, you need to get this naive-based from scikit-learn. Okay. And for pre-processing the text and everything, you need to use count vectorizer. And if you're using Gaussian naive Bayes, multinomial naive Bayes, Bernoulli naive Bayes, you need to define that in exporting of the model. So in the meanwhile, let's understand how this works. Let's go back to the whiteboard where I'll be showing you how this thing works. Wait a second, guys. I'll be setting up the whiteboard within a moment. Guys, give me some response that you all can see my screen right now. So we'll take a real life example and we'll classify whether the email is a spam or not. Okay. So this is a most popular classification task that we'll be performing. So whether we'll be getting to know that the email which you have got is a spam email or not. Suppose for that, what you need to do is imagine you got a new email and you want to classify the email. So it is a spam or not. Our features will with the words what is the features we'll be having. Suppose if it's important, if it's urgent, based upon the features what we're having, we'll be defining the training data set. So for that, first, let's define the training data. Okay, let's take this example. And take me sample data set. This email ID. This is word one. This is word two. This is word three. These are the starting words. What are the most crucial words that we're seeing in this model? This is a class. Okay, let's take 1, 2, 3, 4, 5, and 6. Okay, let's take this one as urgent. Let's take this one as money and price. This meeting, team, project. So if you're having these kinds of codes, whether we'll be classifying that into spam or not, we'll be writing something. So if it is saying that urgent money offer, of course it is a spam. Whenever they're offering something money with something like urgent money offer or something, it is a spam. So your boss or manager sent you a meeting link. No, it's not a spam. You come to free price cash, it is a spam. Report due today. So not a spam because your manager is asking some report. Lunch plans tomorrow is not a spam. Your friend or some other is asking lunch plans tomorrow. Or coming to bat lottery win urgent, it is a spam. So whenever you can see that the factor is that they are forcing you to push forward the details. So you can get a feel that you might miss this chance. You might miss this chance to win a lot of money. So if you take this example, out of 6, the total count you'll be having is 6. Okay, total emails is 6, out of spam are 3 and not spam are 3. Now we are having the probability of spam and not spam is probability of getting a spam email is out of 6 we got 3. Sorry. So what are the spam total occurring outcomes by all out, like favorable outcomes by all outcomes? So favorable outcome is 3. For getting a spam email, it is 3 by 6. So it is 1, it is 2. That is 0.5. So probability of not getting a spam email is the same thing. We are having 3 and 6. Now we'll be getting the same thing, that is 0.5. Initially, if an email is likely to be spam or not, we got to know, but we'll be checking based upon the likelihood. So now if you see the words what you're having, for every each word in our email, free, lottery, and some other things, we need to calculate the probability that the word is appearing. So if the word is appearing in spam, then we need to mark it in a spam email. So if the word is not appearing in a not spam, then we need to mark the words also. So for some spam email, let's get to this. For email is equal to spam. We're having urgent. Okay, we're having urgent 1, urgent 2 times. Okay, so urgent is equal to 2 times. And you can see the next thing is money. Money is only repeated 1 time, right? Okay, money is only repeated 1 time. After that, offer. Offer is repeated how many times, guys? Offer is also repeated 1 time. The next thing is free. How many times the free is repeated? 1 time. The price is also repeated 1 time. Coming to cash is also repeated 1 time. And also the bad lottery and win, this is also repeated 1 time. Now if you take this thing, we have around 9 words in this spam emails. Okay, whenever you're getting the spam emails, we can identify them with the help of 9 words, whatever we're having. So these 9 words are lottery, win, urgent, money, offer, free, cash, price. Okay. Now these unique words in the vocabulary, whatever you're having, say if you're having 15 words around the email, then if you're having the probability that most number of words that you're having, suppose if you see the total words in the vocabulary that we're having in this email, and if this email is so what we'll do in the next thing is we'll also count this for not spam. Okay, let's take this not spam also. For not spam, meeting is 1 time, team is 1 time, project is 1 time. And if you take this everything, report due today, lunch plans tomorrow, everything is repeated equally. Okay, now whatever the things that you're having in spam and not spam, only not spam, the urgent is repeated twice, but coming to spam, everything is repeated only 1 times. Now coming to calculating the probabilities. Okay, if one event occurs, suppose if this word occurs, what might be the chances that we'll be having this email as spam? That is the probability we'll be performing. So based upon the task, you need to perform this operation where what is the probability of this word to appear. Okay, now we need to take this out statement here. Probability of A by B is equal to probability of B by A into probability of B by probability of A. Now this probability of A, probability of B by M, probability of B nothing but suppose as we are taking, so these words whatever we are considering the spam words, as we are taking the urgent is equal to free, one, lottery, money, win, offer, crash and price. So if these words are appearing in our email, that is this thing. Okay, if this event is occurring, that is probability B. Okay, these words are coming out of how many words we're having? Out of 15 words we are having. Out of this 15 words, we are having this 9 words in our vocabulary. So not 15, we are having 30 words. Out of 18 words we are having, if these 9 words are in the vocabulary, then what is the probability that by having these 9 words, the email is a spam email or not? I hope you got this thing. So probability of B is getting these words correct, getting these 9 words in the probability. So if you're having these 9 words in the in the email, so this probability is something. So after that, what is the event that you will be having the email to be a spam email after getting these words in the email? So you'll be getting urgent offer and everything, right? So after getting these words in your email, so what is the probability that you might get a spam email after getting the words in the email? First thing that needs to occur is you need to get these kinds of words. That is probability B. Only when probability B occurs, then probability A will occur. That is the condition here. That is what naive Bayes is. That is what the classification algorithm entirely is. Okay. I hope you understand this. Give me some response that you understood this or not. If you're having any difficulty, then I'll let you know what are the required steps that we need to perform for this algorithm. And some response in the chat, guys. Guys, give me some responses in the chat so that I can understand that you guys have understood this topic. So if this is completed, then we can move on to the next topic. But for that, I need your responses to acknowledge that you have understood this topic. Only when I get to know that you have understood this topic completely, then we'll go back to the next topic. So as we can remember that we only have 2 classes left. So I'll be trying my best to cover what are the topics that we're having so that we'll go with a smooth flow in the project in the last 2 sessions. I'm planning for the project session in the last 2 sessions. So we'll be having a live project that we'll be performing. So from project data collection to deployment, what are the processes that will be there, I will be performing in the next session. But for that, I need to complete what are the remaining topics that we're having. So if you're trying to understand these topics, that's fine. But if it's hard for you to understand, then please drop a message in the chat so that we'll get back to you and we'll explain these things in a very clear manner. And I need some confirmation from you guys that you have understood this topic. Whenever you give me some confirmation that you have understood this topic, then we can move on to the next session, next topic. Guys, if it is understood, please drop a message. Okay, okay, we'll go with another topic. So in this session, we'll be talking about the important steps after building every machine learning model. That is model evaluation. So if we are training a model, the everything is completed. So the first thing we'll be doing is after for deployment, we need to perform this model evaluation. So it's not enough to train a model, but we need to understand how well the model is trained. So to understand how well the model is trained, we need this step called as model evaluation. So think of it like if you're preparing some dish. Okay, after preparing some dish, what you'll be doing is before serving to the friends and family, you will be tasting a small pinch of the dish. Suppose we are preparing a gravy, we're preparing some for some other thing. We will be taking 2-3 drops from the soup and tasting this soup, whether what are the salt, spice, and everything that you add to the dish, that these are in a correct measurement or not. So this is what the evaluation also. So we'll be having different metrics for different evaluations, different models. So we'll be getting to the first thing. So why we need to evaluate is to understand the model performance, how well the model is performing, and if it is underperforming, so we need to improve the model performing by testing more further, and to compare different models. Suppose for a different problem, we can use different models. For a single problem, we can use different models. When you're using different models, you'll be getting to know what model is performing better in these kinds of scenarios. Okay, whenever you understand this model is performing better in this kind of scenarios, then you'll be implementing the model. And from next time also, you won't be wasting your time. You will directly go with the same model that you have used well before. And also to identify the weakness. Wherever you see that this model is not performing good in this kind of scenarios, then you can eliminate the model in the upcoming scenarios. And it is also useful for setting the realistic expectations. Suppose if I want to diagnose a disease. So if I want to diagnose a disease, what I'll be doing is I'll be evaluating the model first. So what are the realistic expectations that you'll be having? That is around 90 to 75%. So if I'm meeting the realistic expectation, so for every disease we'll be having a correlation matrix, and also we'll be having a classification matrix. So based upon this correlation matrix, we need to understand whether the disease we are getting is by far compared to the real world medical diagnostics, which is giving the correct answer or not. So as you know, for regression, we'll be predicting the values, and but for classifications, we're predicting the classifications. So based upon these two things, we'll be performing the metrics. So the first thing we'll be going with is evaluation metrics for regression models. So whenever our machine learning model predicts a continuous numerical value, such as house price or gold price or some other thing, so we'll be using regression metrics. So in this scenario, our primary interest is understanding how close our models predictions are to the actual values. Suppose we are predicting that gold price will be 50,000 tomorrow, but the actual price is 45,000. So how close the value is? It's around 5,000 close. Like it is only 5,000 less than the actual value predicted. So it is the 5,000 measurement what you're having is how close the value is. So the first thing that we'll be using is mean absolute error. I've already discussed this in the next previous session. Let's have a quick refresh, like recap of this. So this mean absolute error calculates the average of the absolute difference between our model's predictions and the actual observed values. Just now we have discovered this thing. The gold price that we're predicting for tomorrow is around 50,000. But when the time is tomorrow, when when tomorrow when you see the gold price, the price is 45,000, you can understand that the price which is around 5,000. That is the only gap that is between the predicted value and the actual value. So this mean what? This what mean absolute error is. Okay, it is mean absolute error is nothing but the average of the absolute differences between our model's prediction. So by taking multiple evaluations, we'll be getting to know that what is the absolute difference that we'll be having between our model prediction and the actual value that we have observed. That is what mean absolute error is. Coming to mean square error, this mean square error is nothing but the calculation that averages the square of differences between our model prediction and the actual values. Whatever the difference that we're having, we need to predict the differences, and also we need to have a square error. The difference that we're having. Suppose the difference that we're having is around 5,000. So what we'll be doing is we'll be performing square of the error, and we'll be calculating the summation of 1 by n. And coming to the next thing, that is root mean square error. So whenever you're performing mean square error, you're just applying square. But coming to root mean square error, whatever the square you're performing, after square is performed, you need to apply the summation of n function. After the complete function is performed, you need to apply the root over function. That is what the difference between mean square error and root mean square error. To see the formula, both of them are same. The only difference that we're having is we'll be having root over in root mean square error. So this is a fourth metric that we'll be having, which is R square. This R square is also known as coefficient of determinants. Okay, so this coefficient of determinants is a metric that will be measuring the proportion of the variance that is dependent and that model can explain. So using the independent variables that we're having, it will tell us whether the model will fit our data or not. So this range will be typically in the range of 0 to 1. Okay, however, it can be negative if the model performs worse than the simply predicting the mean of the target variables. So mostly the range will be of 0 to 1, but if the model is performing worse than the expectations, then the range will be less than 1. So how the interpretation will go is, if R2 is equal to 1, the R square, that is the regression matrix name, that is what it is, R square, that is R2. If R2 is equal to 1, the model perfectly explains all the variance in the target variable. That means it is perfectly good and everything. If R2 is equal to 0, the model will explain none of the variance. It will not explain everything, and it's no better than the simply predicting the average of the target for every single data point. And also we'll have another uh, metric, that is R2 is equal to 0.75. For model is predicting R2 is equal to 0.75, it is our model explaining that 75% of the variability observed in the target variable, the remaining 25% is unexplained by our model. So how much of the data that our model can explain, how much of the data our model will not explain, we will be figuring out in R square measuring. This is what R square is. As we have discussed, this R square is known as a coefficient of determination. And if you look at this XSR or RSR, where XSR is equal to summation of yi minus y cap I whole square. So y cap I is the predicted value, yi is the actual value. So what are the predicted value and actual value difference you'll be getting, and what are the predicted value and actual value squares you'll be doing. So after doing everything, what are the differences you'll be having? Suppose if it is 1, 0, or 0.75, some other thing. So how much the value will be? Whether it is 1, if it is 1, then the model will explain everything clearly. If it is 0, the model will not explain everything. But if it is 0.25, our model will explain only 25% of the target variable. Out of the 75%, it will not explain. So based upon what is the value between 0 and 1, our model will explain this or not. That is what we'll be discussing. Coming to metrics of classification. So the best metrics for classification is confusion matrix. Okay, this is what there is one of the most favorable metrics that you'll be seeing when you're using classifications. So coming to confusion matrix, you'll be having a matrix. Okay, let me just show you if I'm not having an image. So you'll be having a matrix. Okay, remember this thing. I'll just share my screen once again. I hope my screen is visible to everyone. So if you're looking at my screen, what are the terms which are written right now? That is, if this is the inside thing, this is true positive, true negative, false positive, false negative. So this is the values that PP and the PN represents. So PP represents predicted positive and PN represents predicted negative. So what is the values that our model predicted? This predicted, these are the predicted positive values. Okay. So these are the predicted negative values. But coming to this thing, these are the actual positive values. Okay, in the real world, these are the actual positive values. But what our model is, it predicted one is true and another one is false. Okay, so this thing is it predicted negative, and also the model which are having is positive. So let me just explain you. So now let's understand what is this everything is. So the true positive is nothing but our model predicted positive and the actual outcome is indeed positive. Okay. So our model is predicting the positive and the actual outcome is indeed positive. We can look at this example. You can look at this example and coming true negative. Our model predicted negative. Okay. If you can see this, our model predicted negative. Predicted value is negative, but the actual value is positive. Okay. That means the actual value is indeed negative. Coming to false positive, actual value that is negative, and also the model predicted positive. That means, let's take an example for better understanding. Suppose you went to a hospital. Okay, you went to a hospital and they gave you some diagnosis report. So this diagnosis report is regarding cancer. Okay, so this actual positive represents you're actually having cancer. This actual negative represents you're not having cancer. Okay, let's take this example of cancer. Okay, you're having cancer. Absolute positive having cancer, absolute negative. This is the predicted values of your cancer. So actually, you're having cancer, and the machine diagnosed that you have cancer. That no worries, right? Actually, you don't have cancer, but the machine detected that you have cancer. Then you might worry that you that you're having cancer. So this is one of the disadvantage of this confusion matrix, not confusion matrix classification. So whenever, even though you're not having this problem, if the model detects that you're having problem, that is one of the problem. And coming to this thing, true negative, where you're having negative, the cancer is negative. Sorry, the cancer is positive, and the model predicted that you don't have any cancer. Okay, the model predicts that you don't have any cancer, but indeed you are having the cancer. That means if you're having cancer, you need to take some medication, you need to take some hospital, or you need to admit to the hospital and everything. But whenever the model predicts that not having cancer, then what you'll do is you will go outside, you will eat junk again, you will go to parties and everything, you will drink and everything, you will do everything. So whenever you perform these kinds of activities, your cancer increases day by day. Okay, now coming to false negative, the predicted value is negative and the actual value is also negative. That means it is a correct response. Only these two responses are correct. Okay, the true positive and false negative was correct. Coming to this true negative and false negative are incorrect responses. Hope you understood this thing. Give me some response. Did you understand this confusion matrix? We'll be using confusion matrix in every deep learning and machine learning problem. So we'll be understanding the accuracy, precision, and next thing based upon this confusion matrix. If you didn't understand this, I'll explain you again. But give me some response so that I can proceed or not. So the first matrix we'll be discussing classification is accuracy. So how we'll be performing accuracy? So we'll be performing accuracy with total number of outcomes, but let me install this. Accuracy is total number of positive outcomes by total outcomes. Total positive outcomes by total outcomes. So that is, if you look at this example, the total positive outcomes we're having is this example, the total positive outcomes that we're having is 2. Out of the total outcomes that we're having is 4. And then the 0.5 probability. I hope you understood this thing. Now, the next thing we'll be discussing is precision. Share screen. So this is what we have discussed until now. So accuracy is nothing but the total positive outcomes by total outcomes that we are having. So total positive outcomes which we are having is 2 positive by 2 negative. The total outcomes we are having is 2 positive, 2 negative, 2 false positive, and false negative. So the outcome that we are having is 2 by 4. That is 0.5% accuracy. So coming to precision, the precision is nothing but out of all the instances that we have predicted. So how many instances that we have predicted positive? So this is precision is mostly used for minimizing the negative values. Okay, that is the false positive values. So precision focuses exclusively on the positive predictions that we are having in our model. So it answers crucial questions like for all the times our model said something was positive, how many times the model predictions were correct. Okay, so if the model prediction told it is correct all time, so how many times that model is correct? So what it's doing is it told correct only one time. Out of this correct, how many times it is correct? So by that is true positive is only told one time. It told false positive one time, true positive one time. Okay. So coming to this true positive, out of this true positive plus false positive. So this is the outcome of precision. So the next metric that we're having is recall. Recall is also known as sensitivity or the true positive rate. So how many true positive rate that we're having? So known as the actual positive cases within your data. So as we have recalled this thing, so recall is equal to true positive. That means it gave positive and it is also positive by true positives. So actual positive, how many are having by true positive, how many it is predicted. So true positive by true positive plus false negative. So coming to this next thing, that is F1 score. F1 score is nothing but F1 score is a powerful metric that provides a balance between precision and recall. It's specifically for the harmonic mean of precision and recall. So if you look at the formula, this metric is especially useful when you need a single value that considers both type of errors, false positives and false negatives. So F1 is equal to 2 into precision into recall by precision plus recall. If you want to use this both the functions for understanding what is the positives we are having out of entire positives and what is the positives out of we are having, like, or what is the negative, what is the way to minimize the negatives, then we can use F1 score. So next thing we'll be learning is ROC curve and AUC curve. So ROC and AUC is the area under the curve. Okay. So this area under curve for binary classification problems, we frequently use this ROC curve and AUC curve. So many classification models, they don't just give you the yes or no output. Okay, they will predict example 80% or that we'll be having a disease, 90% will be having a disease and some other thing. So whenever we are having these kinds of thing, we'll be applying a threshold area under the curve. So if this area, if we are having 90% of the area under the S curve, then it is given as yes. If we are having 80% under the area of curve, then it is given no. So based upon the data what we're doing, we will be giving the outcomes based upon the curve data and also the area data we'll be having. Suppose RBC curve, coming to this curve graphically plots the true positive rates. Okay, this will give the true positive rates and also which is the same as the recall. So again, the false positive rates at various possible classification threshold settings. So coming to AOC, AOC is a single scalar value that represents the area under curve. So it provides a comprehensive summary of all the performance of classifier across all possible classification thresholds. So you'll be using AOC and ROC curve are excellent for imbalanced datasets. Whenever the datasets are imbalanced, we'll be using these things and also practically useful when we need to understand our model's performance. And also across different decision thresholds, the AOC is generally less affected by class imbalance than a single accuracy score. When we'll be having imbalanced datasets and also the datasets will be having not data, then we'll be using AOC and ROC. So at that time, whatever imbalanced datasets will be having, our model needs to perform across different decision thresholds, not only by taking one evaluation metric. We need to perform across different decision thresholds. Then we'll be using this AOC and ROC. So this is what AOC ranges from 0 to 1. So 0.5 is something like guessing random. 1 is perfect classification. A higher AOC indicates better discrimination power. So based upon these things, you can go with AOC or ROC. So overfitting is something which we'll be seeing mostly when you have all training the data points with all data points. And when you get a new data point, you'll not be able to identify what is the data point we'll be using to perform the classification. Underfitting also it's something which is too simple for the model. So model will be trained upon data, but whenever you will be giving some complex data, model will not be able to perform. It's like you have learned something, but whenever you try to learn something complex, you will not be able to answer this thing. Because whatever we learned is the basics of the topic, but coming to the complex of the topic, you'll not be able to answer because you didn't know about this complexity. So bias was variance trade-off is nothing but whenever you're having high bias, we'll be having the data underfitting. Whenever you're having high variance, you'll be having overfitting. So if one gets decreased, if you want to decrease high bias, variance will increase. If you want to decrease variance, bias will increase. So bias variance trade-off is nothing but you'll be occurred to maintain low bias and low variance. Okay, so maintaining this low bias and low variance is called as a sweet spot. So the balance optimized general application of this sweet spot is called as bias and variance trade-off. So this is what model validation. So why do we need to ensure the real world performance? Okay, so we need robust validation techniques so that we'll be using this evaluation metrics so that we can understand what is the right model for our model for our problem, and also we will be able to understand and when and where we'll be using the model for the probability metrics. So cross validation is used when instead of one train and test split, whenever you use cross validation, suppose if you look at this, if you look at these two things, this imagine these three things are data sets. Okay, the data is being split into 3.3, 3.3, 3.3. Now, this data, when you can be using one for testing and two for training, one for testing and two for training. Instead of using this one part, what we'll be doing is at one stage, you will be using this one for training, this two for training and this one for testing. And at one stage, you'll be using this two for training and the middle one for testing. At one stage, you'll be using this two for training and the first one for testing. So what this cross validation will do is at every stage, it will train the model with the test and train data split. So it provides more reliable estimate of model performance. So whatever we'll be doing is it reduces the impact of lucky or unlucky single split. Whenever you're doing the single split, you won't be knowing where the crucial data is, okay, where the complex data is. You need to train the model with complex data. So whenever you're doing this cross validation, our model is being trained with multiple splits of the data, so that every split is important for the data validation. So if you look at the k-fold validation, k is nothing but the number that we'll be discussing in KNN, just like that what we'll be discussing. So the data is divided into k equal folds. And after that, every time the data is being trained, k minus 1 folds are used for the training. Okay. So whenever you're using k minus 1, this one fold that we're using is for testing. If you look at this thing, out of 5 things, I'll be using this one for testing first time, middle one, and the middle one, and this middle one again, and we'll be using the first one. So whenever you're using multiple testing points, then you can understand that entire data what you're having is being trained by the model. Now, what a probability for you to get the exact accuracy for the problem. So test train split that we have already discussed in the previous class that we are having, and also random set ensures that the data is being split into exact propositions, and also that we'll be having random data sets that will be divided into multiple applications. So we have developed this confusion matrix. Confusion matrix will be used for byte and Y prediction. So for prediction, for precision, recall, and FR score, we'll be using classification report function. Okay, these functions are imported from scikit-learn, and also we'll be using Y test and Y prediction classes labels. These are also the metrics that we'll be using for, as we have discussed, AOC and ROC curves. Okay, we'll be using scikit-learn to get the metrics and everything. Remember this thing, MAE, MSE, RMSE, R square. These are the things that we'll be using for regression. Coming to classification. We'll be using confusion matrix, accuracy, precision, R1 score, like accuracy, precision, recall, and R1 score. So based upon these things, we'll be evaluating the model. And also applying k-fold cross validation. So for using k-fold cross validation, we will be importing scikit-learn. So as we discussed, scikit-learn is mostly important for machine learning models. Whenever we are importing something regarding machine learning, we need to import scikit-learn. So whenever you import the scikit-learn, what are the things that we're using for evaluation metrics to model deployment, everything will be importing from this sklearn. Okay. So that means you need to import this from scikit-learn. And once you import, it will be easier for you by writing 3-4 lines of code. So that's it for today, guys. I hope you understood this session. If you're having any doubts right now, please try to ask your doubts in the in the chat box. So if you're having any doubts, please try to ask them in the chat box now itself. If not, we'll be ending the session right now. So the end date for your projects that you'll be performing is tentatively, we can estimate until the end of the upcoming week. From next week onwards, we will be starting your projects. We'll be having a project orientation, and you will be having a dedicated session for project out solving and everything. Okay, from tomorrow, we'll start how to prepare the project. And I want you all to prepare the project from tomorrow itself. Whenever I'm performing this project parallelly, I want you all to perform this project. And while I am doing this project, I'll explain you how to do and everything. Okay, please look at tomorrow's class. And that means the day after tomorrow's class. In the upcoming class, we'll discuss how the project flow will be, how we'll perform the project and everything. I'll take an end-to-end project of this machine learning, and I'll so you can take your wish to register for the projects. I didn't get you when you mentioned same or different. Also, can you please repeat what I need to explain again? It's upon your choice. Everyone is not titled to take the same projects. So if you want to take same projects, then you are prompted to. So we'll inform everything about projects in the upcoming week. So this week, the upcoming week is dedicated for project sessions. So until this weekends, we'll only concentrate on the theory and the practical part of the how this program like is being done. But once next week starts, we'll be performing this practical on your own. So let me just explain confusion matrix once again. We'll be having a table. In this table, we'll be having values such as true positive, true negative, false positive, false negative. So just get them. This is what true positive is. This is what true negative is. This is false positive. This is false negative. Okay. So this is predicted values, predicted positive, predicted negative. This is actual positive, actual negative. Actually, check this example. Actually, you don't have any cancer. Okay. Actually, this is regarding cancer. This example, you can take this as cancer diagnosis, where you can take this example, that is, you went to a machine learning model and you have given this thing. Okay, now what it predicts is, so if you look at this actual, these are the actual positives. Actual positives represent, suppose if you're having true positive, that means it gave positive whenever you're having positive. Okay, actual positive is done, true positive is done. Okay, now whenever positive combines, it will give true positive. Now, actually, in the real world problem, you're having cancer, and machine learning model also gives cancer. Okay, now coming to predicted negative, now what this does is, so actual value you're having positive. Actual value says that you're having cancer. But what this machine learning model says, this machine learning model says you're having no cancer. Now it is giving false negatives. It is giving negative value, but it is false value. Okay, it's giving a negative value. It's giving a negative that cancer is not there. Okay, it is giving a negative, cancer negative, but it is false. Okay, I hope you understood this thing, because actually the value is positive. Actually, the value is positive, but it is predicted false negative. Now coming to this actual negatives, actually you don't have cancer. In these two things, you don't have cancer, but the model predicted positive. It has given positive. That means cancer is given positive, but it is a false value. Okay, actually it is negative, but the cancer is given positive. Actual the value is no cancer, but the model what it given is, it has given you cancer. So it's a wrong thing. So whenever you're not having cancer, it is giving cancer. So in this both cases, if you observe, if you're having cancer, it will not give you cancer. You're actually having cancer. Patient is having cancer, but the what it is doing, the model, it is not giving cancer. It is not giving that you're having a cancer. But coming to this thing, actual negative, false positive. Actual value is negative. That means you're not having any cancer. But coming to this thing, false positive, it is giving you falsely positive. That means Even though you're not having any cancer, it's telling you that you're having a cancer. Coming to true negative, it says that you're not having cancer by machine and you're not having cancer by actual value. Okay, I hope you understood this thing. These two are positives. These two are negatives. False negative, false positive are incorrect values. True positive, true negative are correct values. I hope you understood this thing. Huda? Huda Kaushal, please give me some response that you understood this thing or not. So apart from Huda, if you're having any doubts, please mention them in the chat box. Or else we'll end the session in a minute. So guys, thank you for joining the session. Have a good day. Have a great night. Bye.